Welcome to lecture 7 of financial risk management. For last two lectures we are discussing the concept of interest rate risk and we are going to continue this topic in this lecture 2. So we have explored some idea of Macaulay duration and in this video we are going to see how do we calculate Macaulay duration, and then there is a second technique which is called modified Macaulay duration. We are going to look into this technique as well. So we have already seen it is developed by Frederick Macaulay in 1938 and it is a weighted average maturity of the cash flows. And this was the formula, but let me explain this formula. Okay, so let's have an example and then I would explain this formula. So the example is find the duration of 5 years of a coupon bond. So this bond matures in 5 years, its maturity is in 5 years, its coupon rate is 5%, which is the interest rate, and the current prevailing market interest rate is 7%. So this would be our R. The face value is 1000. Let's go back to the formula. So there are different methods of solving this Macaulay duration, and you would find different formulas as well. I would explain this using the formula, and then there is a simple method of solving this question. Let's look at the formula and then we would see the simple method. Okay, so this summation starting with t is equal to 1 and ending till n. So in previous example we have a 5 years of maturity, so n would be 5. So this whole part is basically finding the present value of all the interest rates, all the coupons, and basically multiplying it by 3 we find the weighted cash flows. And similarly this m is basically the par value, which is the 1000 in previous example, and finding the present value of that par value, multiplying it by n would give us the weighted par value. Then we have bond price divided by bond price. So how do you find the bond price? So bond price is equal to C into 1 minus 1 divided by 1 plus R raised to power n divided by R plus the face value divided by 1 plus R raised to power n. So let's solve this question and it would give us a better idea. So this is the question. So first we need to find the bond price. Bond price is equal to C into, remember this is the annuity formula, 1 minus 1 divided by 1 plus R raised to power n divided by R plus the face value divided by 1 plus R raised to power n. So if we plug the values, so C in this case would be 50. Why? Because it is a 5% coupon bond and the face value is 1000. So 5% of 1000 would be 50 rupees. So 50 into 1 minus 1 divided by 1 plus R is 7%, not the 5%. 5% is just the coupon rate, whereas the market interest rate is 7%. So this would be our R, which is also the YTM. So 0.7 raised to power 5 divided by 0.07. So this would give us the present value of all the interest or all the coupons that we would receive. Then we have the face value. This part of the equation would give us the present value of the face value raised to power 5. If we solve this equation, then the total that we get is 917.35. So this is the bond price. Okay, let me erase this and then we solve the rest of the equation. Okay, the formula for Macaulay duration is summation t is equal to 1 till n c into t divided by 1 plus r raised to power n plus n into m is the par value divided by 1 plus r raised to power n, this whole divided by bond price. So if you find initially this part of the equation, then that would be finding the present value of each cash flow. So the cash flows are so we have how many time periods do we have? So let's first solve this part of the equation. So we need to multiply the interest amount, the coupon amount with each time period and then find the present value. So let's write the equation. Okay, so this would be 50. So if coupon is 50 multiplied by 1, the time period is, this is for the first time period, divided by 1.07 raised to power 1 plus 50 into 2 divided by 1 plus 0.07 raised to power 2 plus 50 into 3 divided by 1.07 raised to power 3 plus 50 into 4 and similarly for the last year. Doing this, we would find the answer of this part of the equation. So let's solve this. We get these values from each of these equations. And if we estimate, sum them up, we get 587.30. So we have solved this part of the equation. Let me clear this, or let's solve it over here. We are left with this part of the equation, right? And this part of the equation would be equal to 1000 into 5 divided by 1 plus 0.07 raised to power 5. So we get 3564. Okay, so if we put these values into this formula, so Macaulay duration is equal to, the sum of this part of the equation is 587.30. The answer to this part of the equation is 3564 divided by the bond price we calculated previously is 917.35. So if we solve this, we get 4.52. This 4.52 is in years, right? The answer would be in years. So what this means, let's say if there is a bond whose Macaulay duration is 5, and then there is a bond whose Macaulay duration is, let's just say, 4.52. Which bond is more riskier? The bond with the higher Macaulay duration. This one would be more riskier as compared to this bond. So now if we wanted to remember, we had a question in previous lecture where we discussed two types of bonds, the one with 20 years of maturity and 9% coupon rate. The question was which one would have a higher interest rate risk. So by doing this Macaulay duration, we can find the we can estimate the interest rate risk of a bond. So this was one of the way of finding Macaulay duration. Let me show you another way, and I have seen that students find that that method of solving this question quite easier. So for this we would draw a table. We have this time period, then we would have a cash flow column, then we would find present value of each cash flow, and then we would find weighted present value. So in this case we have 5 time periods. The cash flow for first time period would be 50 because that would be the interest we would receive, then 50, and in last year we would receive the 1000 principal amount and as well as the 50 of the interest amount. So let's find the present value of each of these cash flows. We know how to find present value, divided by 1 plus 0.07 raised to power 1. For this we would do it like this. So the present value would be 46.73, 43.67, 40.81, 38.14, and for the last one we would have this one. Then we multiply it with the time period and we get 46 multiplied by 1 would be 46.73, 43.67 multiplied by 2 would be 87.34, 22152, and then we have 3740. If we add them up, we would have 917.35. Remember, this is the price of the bond price that was denominated in previous formula, and this is 5.4152. This is the numerator part. So to find macular duration, it would be sum of weighted present value, that is this column, divided by the sum of present value. So 4152 divided by 917 would again give us the same answer, which is 4.52. So whichever method you find easier, you can use that specific method. They both are same, they would give us the same answer. The only difference is the method of solving a question. Okay, so what is the interpretation? The bond with the higher macular duration are more sensitive to changes in interest rate, thus its price is more volatile. So the bond with higher macular duration is more riskier, it is more sensitive. A zero coupon bond that lasts n number of years has a duration of n number of years. What this means is that previously we saw a bond whose maturity was 5 years had a macular duration of 4.52 years. So macular duration was lesser than the time to maturity because it is a coupon bond. And this is what this sentence says: a coupon bond, remember a coupon bond is the bond that pays us a coupon, lasting n number of years. So in this case it lasts 5 number of years, maturity is in 5 years, has a duration of less than n years. So its duration is macular duration is 4.52, which is less than 5. So whenever we have a coupon bond, the maturity will be less than the maturity of the bond. But in case of a zero coupon bond, the macular duration would be equal to the bond's maturity, which is n. So if there was a bond whose face value was 1000 and its maturity is in 5 years, because it is not paying any coupon, then this part of the equation, which is t into c divided by 1 plus r raised to power n, is we do not need to solve for this equation, right? This part of the equation, because there are no coupons. So anyhow, you can try it yourself. The answer, the idea is that if there is a zero coupon bond that do not pay any coupon and its maturity is in 5 years, then its macular duration would also be 5 years. You don't need to estimate it. There is another example. Patty holds a 5-year bond with a par value of 1000 and a coupon rate of 5%. For simplicity, let's assume the coupon is paid annually and the interest rate is 5%. So this is R. What is the macular duration of this bond? So again, you can find the macular duration. I would leave this question to you for practice purposes. Okay, then there is another example. Suppose investor holds a 2-year bond with a par value of 1000 and an annual coupon of 8% with semi-annual compounding. Now this is interesting because previously we were doing annual compoundings. This time we have a semi-annual compounding. Yield to semi-annual compounding is 10% per annum. So what is the macular duration? Okay, so we need to find the macular duration. Let's use that simple method of drawing a table. So we have time period, we have cash flows, we have present value of cash flow, and then we have weighted present values. So in this case we have 4 time periods because this bond expires in 2 years and there are semi-annual compounding, so we get interest after every 6 months. So there are so we have 4 time periods. In each time period we would get an interest of 40 rupees. Why? Because if 8% is the interest rate and 1000 is the par value, so after each 6 months we would, instead of getting 8%, we would get 8 by 2%, that is 4% of this 1000, because annual interest rate is 8%, but it isn't the semi-annual interest rate. It is compounded semi-annually. Remember, when we say compounded semi-annually means that if interest rate is 8%, then compounded semi-annually means that we would receive 4% after 6 months and then again 4% after further 6 months. So each time period we would receive a 4%, which is 40 rupees, and in last year we would receive last time period we would receive 1040. Let's find the present value. Again, present value would be equal to 1 divided by 1 plus 0.05 raised to power 1. Okay, so let's write the values. It would be 38.04, 36.24, 34.55, and then we would have, if you multiply this with time, then we would have these values. If we sum them up, then we get, and let's find macular duration. So macular duration would be equal to 3639 divided by 964. So this would give us 3839 divided by 964. So we get an answer of 3.98. Remember we said that macular duration should be less than the number of years, but in this case we are getting 3.98, which is greater than 2 years. But remember, this is not number of years in this case, it is the number of time periods. So if we divide this by 2, then we get, because it is a semi-annual compounding, we get 1.88. Now this is the number of years. Now they are less than 2, because we said that if it is a coupon bond, then the macular duration would be less than the number of years of the bond. Okay, so this brings us towards our second analysis technique, which is modified duration. The modified duration is most risk relevant year. Why is that so? Because although macular duration tells us the answer in number of years, it do tell us that which bond is more riskier, whether bond A is more riskier or bond B is more riskier. If we compare their macular duration, the higher the macular duration, the more would be the risk. But it do not give us the answer that if interest rate increases by 1%, by how much percent would the bond price decrease? Right? This is what most of the investor would want to know. If the interest rate changes by 1% or by 2%, what would be the percentage impact of that interest rate change on their bond value? For this we use modified duration, and it gives us the percentage change in bond price given a 1% point change in the market interest rate. The formula to find modified duration is -1 into macular duration, whatever macular duration we find using the previously taught methods, divided by 1 plus YTM. YTM stands for yield to maturity. It is R in our previous examples. Then we have M, which stands for frequency of compounding. Remember, if it is a semi-annual compounding, then frequency of compounding M would be 2. If it is quarterly, then M would be 4. If it is annually, then M would be 1. If it is monthly, then M would be 12. Then we have change in interest rate. It should be in decimal form. By the way, this -1 is just used to input the idea of inverse relationship between interest rate and bond price into the formula. Okay, let's have this example. You have a 10-year 8% coupon bond, and the current market rate of interest is 7.25%. This is YTM, this is coupon rate. We have a 10-year bond. This bond will have a macular duration of 7.32. The macular duration is already given in this example, but if it isn't given, then you need to find it. If the interest rate falls by 80 basis points, what will happen to the bond price? So now it is asking us the question, it isn't asking us which bond is more riskier. It is asking us if the price changes by 80 basis points, what would be the impact on the bond price. First of all, what is basis point? Each percentage contains 100 basis point. So 80 basis points simply means, if we divide it by 100, it simply means 0.8%, right? Not 1%, 0.8%. So if we solve this, then we have, let me put the formula. It is macular duration divided by 1 plus YTM divided by M into change in interest rate. So -1, our macular duration in this case is 7.32 divided by 1 plus YTM. YTM is 0.0725 divided by M. Now in this case M would be 1 because there is it is an annual compounding, right? Then multiply by change in interest rate. Remember, the change in interest rate is how many basis point? It is 80 basis point. What is the percentage? 0.8%, but we do not need to write 0.8% over here. Remember, we need to write this I in decimal form. So we further divide this 0.8 by 100, so we convert this percentage into decimal, so it would be 0.008. The answer would be 5.46%. What this means is that if interest rate increases by 80 basis point, then the bond price, sorry, in this question it is asking us if the basis point falls by 80 basis point, interest rate falls by 80 basis point, then the bond price would increase by 5.46%. Remember, there is a positive sign. Sorry, we didn't multiply it. Okay, so it shows the inverse relationship, right? So if if interest rate decreases by 80 basis point, then the bond price would increase by 5.46, or the other way around. There is another example. Betty holds a 5-year. This is the same example that we discussed previously. What is the modified duration? So first we need to find Macaulay duration, because Macaulay duration is not given over here. Then we need to find the modified duration. Remember, there are 120 basis points. So 120 basis point means it is 1.2%. But in the modified duration formula, we won't write 1.2%. Rather, we would write 0.012, right? So it should be in decimal points. Okay, this is it for this lecture, and in next lecture we would further explore the other aspects of interest rate risk.